Now let's do some more practice in estimating a limit numerically. Now really all we're doing with these is we're plugging it in a calculator to help us out to figure out what the limit is going to be. Now if you take a look at this example, notice we have the limit as x approaches 0 of x over the square root of x plus 1 minus 1. Now, if we actually tried to substitute and plugged in 0, we are going to get 0, square root of 0 plus 1 minus 1, which is 0 over 1 minus 1, which is 0 over 0. So looking at that, you're not allowed to have that, and later on we're going to learn that's an indeterminate form. So what we have to do at this point is we have to estimate the limit numerically. So this is why we practiced with linear functions in the previous example. And so now we don't have that. It's not linear. And so it's a little more difficult to figure out. Now it's telling us the limit as x approaches 0. So 0 will be the number that we're trying to figure out we're approaching. And we already know that it is undefined at this point because we get 0 over 0, and that's not allowed. And so we're going to pick numbers that are very close to 0. So to the left of 0, let us choose negative 0.0001. Then to the left of that, negative 0.001. And then one more, negative 0.01. Then to the right of 0, we're going to choose positive 0.0001, and then 0.001, and then 0.01. So now this is just a matter of plugging it in your calculator and finding the answer. And so when you plug it in, you will find that the first answer, negative 0.01, is 1.994. I'm going to round it to 99. So 5 decimal places here for now. And then the next number, I would get 1.99950. The next one would be 1.99995. And then at 0.0001, that's 2.00005. The next one is 2.00050, and the next one is 2.00499. So knowing that we have 1.9995 here and 2.00005, not sure if I said enough zeros or enough nines, but notice, what does it look like it's going to be? Now it looks like that it's going to be 2. Okay, so we can say that the limit approaches 2. Later on, I'll show you how to plug this into Desmos and then make it a table, and that actually makes it a lot nicer because you can just edit the x values that are in there with your equation, and then you can look at these numbers here, which is pretty fast. And then you also get to see the graph, and so you'll see that at 2, if you were to put your cursor right over that 2, you would notice that it's going to be undefined right at that point. Pretty cool. So try out this example down here. Use a table to estimate the limit numerically. So it's just practice and plugging it in your calculator. There is a shortcut where if you can arrow back up into that equation, you can just edit it. Or if you're using like a fancier calculator, I think you press second and enter, but something brings down the equation again, and you could just reuse the equation and just edit the x value. So try this example out. So in this case, we're trying to approach 1, right? So again, this is telling you what it's approaching. So that's going to be the center number. To the left of that, you could choose 0.999 and then 0.99 and then 0.9. To the right of that is 1.001, 1.01, and 1.1. So I find sometimes that this may be difficult for you in trying to choose the numbers to the left and to the right of it. So you would notice that if you tried this out, you would see that the limit approaches 0.2. So let's get some more practice in estimating a limit. Again, we are using a table, so doing this the long way. We're going to estimate the limit as x approaches 1 of x cubed minus x squared plus x minus 1 over x minus 1. Now you may see, yes, that we could divide this, but that's not for till the next section. But so for now, we're getting practice in plugging in these numbers. So we are, again, approaching 1, so that's going to be the center number. To the left of that, left of 1, it's 0.999, and then 0.99, and then 0.9. Then after, to the right of 1, that's going to be 1.001, then 1.01, and then 1.1 is further out. If we tried to plug in 1, notice, if I tried to plug in 1, it would be undefined at that point. So we really don't know what that is. So one way to figure that out is by plugging in these numbers and seeing what is it approaching? What is the value approaching, the function approaching? So if you plug in 0.9 into your calculator, you would get 1.81. 0.99, you get 1.9801. 0.999, you would get 1.9980. Then you plug in 1.001, you'd get 2.0020. If you plug in 1.01, that's 2.0201. Plug in 1.1, that's 2.21. So looking at this, we have 1.9980 to the left of 1 and 2.0020 to the right of 1. So we are approaching 2. So try this example here. Estimate the limit as x approaches 2 of x cubed minus 2x squared plus 3x minus 6 using the table. So trying this out, you would get 6.6 if you plugged in 1.9, 1.99, 1.999, and then to derive that 2.001, 2.01, and 2.1, you would find that this limit approaches 7.